No one should be stuck inside a toothpaste tube for more than 3 hours. That's my opinion. That's the absolute limit. After that, it actually, I think, it breaches your human rights.
Welcome back to Continuous Delivery Office Hours, where we delve into the topic of modern software delivery. I am your host, Tony Kelly, and I'm joined by our regulars, Bob Walker and Steve Fenton. And you may remember, if you caught last week's episode, we talked about continuous delivery and that meaning that you should be able to deploy at all times. And we're going to follow on that conversation this week with, I suppose, that the next question is how do we know if it's deployable or not, the thing that you're working on? So I'm sure there'll be plenty of nuances that we need to sort of dig into, and various probably examples that you've came across in your time, Steve or Bob. But I'll follow the same pattern as last week and pass it over to Steve if you want to give us an intro to the how behind this.
Yeah, I suppose I'll start with a real life story of a development team that I was brought in to lead. And they were very close to the go live date for something they'd been working on for a while. And there seemed to be some confusion in the leadership of this organization about whether this date was actually going to be feasible or not. And they were regulated, so they needed to be able to deploy the software in order to meet their regulatory needs. And the changes that were being made were the ones that were needed. So I just, like, in the team meeting, gathered the team together. How's it going? Little chat. And I said, so how does everyone feel about deploying this software version? And the room just went silent. No one wanted to say anything. And it was like the longest awkward silence ever. Everyone was just like looking at each other, seeing if someone else was going to say something. And so this is like the canonical example of one of two things: either a team that don't know if their software is good enough to deploy, or a team that knows full well that it's not. It could have been either one of those two situations. So yeah, this is a crucial topic. We have to, if we're going to keep our software always deployable, we need a little green light somewhere that says that it is, right?
Yeah, absolutely. And it's funny you mentioned that because I ran into kind of something very similar where I joined a team and I remember just talking to them and saying, "Oh, I said, well, how long are we going to be testing this particular version that we're about to push out?" They said, "Well, we've allocated a month to testing this, like a month to test it." And so that's really kind of the way that I've seen folks in the past go through is like they go through this rather extensive suite of tests. And oftentimes, especially at the very beginning, it's very manual. They just run through it and they just try to figure out, okay, is this working? And then if they discover a bug, then they will fix the bug or a whole host of bugs will be fixed. And that's exactly what happened with this particular team I was on. I think we fixed like 50 or 60 bugs in one particular instance. And then we pushed it back out. And then basically everyone had to start all over again with all the tests. And it was all very manual. It was all very click opsy. And I was like, that is something. But that was the only way they felt confident in whether or not it was quote unquote deployable, because really the only way you know it's deployable is to test it. And the only way that you can test it is either you do it automated or you do it manual. And those are really kind of the two options that you got.
And this is where I know that in the continuous delivery book, the importance of automation comes through loud and clear.
Mm-hmm.
You can't have a 3-week haul of trying to work out if the software can be deployed, because for that whole 3 weeks you can't deploy it, which means you're not deployable. So I suppose there's a process to go through whereby, first of all, you have to understand what your deployment pipeline looks like. And on day one, it's we cut some kind of version of our software and we deploy it, and then some people manually test it. And then once they're happy, which might take a few rounds, it then goes into some release management process where people maybe get a clipboard out and we sign things, and it's like that might be the day one picture, but let's like get that written down and visualize it, because that's quite a strong moment. And then we should be asking, what automation can we bring in that is going to bring this 3-week timescale down to something that is, and the goal is, it's not an actual time, the goal is it should be continuous. You should know when you commit your code, you should know within 5 minutes if something silly has happened, and you need to fix like, oh, I can't even log in because something's gone wrong, and like the basic stuff. And then you might wait a little longer for a more comprehensive set of acceptance tests. And then you get into the more advanced stuff, right? How can we run our security scanning and maybe we're running like vulnerability tests and stuff as stages in this pipeline, but we can support a lot of that with automation. And we can make sure that if there are any human steps in here, the humans don't touch it unless all of the robots have said it's worth looking at. That's one of the great things about this. So you don't have to test the bit of software 20 times and find a new thing every time. The ideal should be that you're really doing exploratory testing and trying to find the things that may have been missed, because you've got high confidence that the automated tests have made sure that you can log in and you can go and edit your email address and you can buy something in the shop or whatever it is that your software does.
It's funny you mentioned all that, bringing in automation. And one of the things that I think always surprises me is some of the mental gymnastics and the configuration gymnastics people will do to kind of avoid getting into that automation. So I've seen situations where we actually have stood up static testing environments, multiple testing environments. That way we could have multiple streams of work that could be going on at the same time. And that way we're not blocking anybody. So if there is a 3-week moratorium on, say, testing a major release, we can still go through and we can test, say, a minor release or a bug fix or a patch or something like that. That way we don't block anybody. That part to me is always really fascinating to watch all the just the various extra time that you spend to try to get around some of these core problems. But to your point of bringing in the automation and adding in the automation, it is not a cost-free thing to do. You can't just slap on, your automation hat and say, okay, now we're ready to start doing it. If your application's been around for 10, 15 years and it hasn't had any unit tests whatsoever, it's almost a virtual guarantee it wasn't written to be testable. And so it's an architectural change in a lot of ways to make things testable. I don't know how well you can see it, but I actually have right behind me the art of unit testing. So this is actually that was unintentional. I didn't know we were going to talk about that this week, but I just have that up there because it's one of my favorite books. And that was one of the big things he walked through is in that particular book, Roy Osherove, he walks through how to basically make your architecture testable.
That's so crucial.
Yeah, it's a huge mindset shift change. Starting to adopt this mindset of, okay, how can I isolate my code? How can I make it more testable? How can I find all of the different edge cases? And how do I do it's really kind of how do I do just enough testing to make sure that I pass all my unit tests and I don't end up in a situation where I'm doing testing to just do testing to just do testing, that type of stuff.
How does that play out then, Bob, in that scenario? You've kind of got two scenarios then. Somebody is a greenfield and they can kind of do it as they go, and it's probably an easier path because they don't have the legacy stuff to deal with. But somebody who's kind of well down the path already, how do they reverse back out of that? Is it a re-architecture? Is it a big shift, or can they sort of piece by piece?
There are whole books written on this very topic. I think the most common pattern that I've seen in the past is probably the strangulation pattern, the strangler pattern, strangler fig pattern, which is you write the code that is testable and you start making it testable and you start doing it module by module or piece by piece by piece. And slowly but surely you start strangling the old functionality that is not testable. So you almost abstract that piece away. Uh, and you can do that one of two ways. You can do that inside of the code base itself, which carries its own set of risks. But the advantage is that at least everything is in the same code base and you can see it happening in real time. But it adds a tremendous amount of complexity. You have to worry about how am I going to interface with this? How am I going to interact with the non-testable code versus the testable code? You have to end up creating these wrappers and adapters so you can have these two different modes of communication. Or you can start doing things where you start breaking it out into individual services.
Yeah, and I think the idea is that the strangler vine, this is how it kind of takes over an area of woodland that kind of grows up an existing tree. And like there's a tree with a vine on it. And then if you go back and look at it later, there's no tree. There's just this vine, which has kind of just completely replaced it. And that's the idea, is that you're looking, I think it might be Mark Seaman that called these things seams. you're looking for these existing seams in the code that you can kind of get into to kind of like pull things apart a little bit so that you can then test this piece, and you've got a way of getting into there and testing that functionality. And you don't have to try and do it all on the first day. Like, there are probably areas of your application that are super important. If you're working in e-commerce, your checkout process, searching for products, this is going to be crucial. And if there was like a minor bug somewhere on like the, you know, some kind of about us page, it's probably survivable. So you can focus your tests initially on the highest risk areas. And like Bob said, this is like, it's not zero cost, but it's a really good savings account because um, you know if you have entirely manual testing and then you take a section of that and spend time automating it, you never have to repeat that manual set of tests again because that's now taken care of. So each time you're doing a deployment, you no longer have to do that 10, 15 minutes, right? So it doesn't take you long to recoup and then start benefiting. And then you can use that time to go back and do the next piece. And so you kind of, in stages, you build up this really big return on investment by doing automation. And that's test automation, it's security scanning, it's deployment automation, it's having observability that tells you when something goes wrong so you can respond to it before customers are impacted. It's all of these things that can assist us to do a better quality job.
Yeah, and I think the concern that I always come back to, because you came back to the cost, and everyone is cost sensitive, but they're also very time sensitive. And there's always this case of, oh, well, if we write these unit tests, that's going to take an extra amount of time to do that. So there is this investment of, because you have to treat it as production level code. You can't just write the test and say, who cares about this? It's just as important as the code that's going to be running in front of your users or your customers. And so, because of that, that's why you need to make sure that you properly invest in it. And that's, unfortunately, when it comes down to it, if you don't invest in it, or you don't have buy-in from your managers or your leaders, when it comes time to meet a deadline, that's typically the first thing that goes out the door. It's like, oh, we don't need to write those automated tests. We can just manually test everything, not realizing that that's a problem that's going to end up costing them later in the future, because now they're going to be spending all this time manual testing. So to save a little bit of time now, they forego. Basically, it's a lot like investing. Have a little bit of go out and buy the thing, ball out, buy this really fancy new widget or buy this fancy new computer or whatever the case may be now, versus investing in your future. You get that you get that kind of that dopamine hit right now, but then later down the line, you're going to be kind of stuck. Not going to be you're not going to be as good of a state as later.
Yeah, and I think it's one of those problems that by the time you learn the lesson about how much it's costing you by not doing those tests, the problem of solving it is now out of hand as well because you didn't write them as you went along.
Yeah.
And I think it's a super old study. I think it comes from the early 2000s, and it was a joint Microsoft and IBM study, and it said it can take you 40% longer to implement a feature if you're writing the test alongside it, but it pays itself back in a very short time window after you've actually completed the feature. So it's like, yes, you're going to spend a little bit more time, and if you're working in small batches, like, I mean, if you're delivering a feature in a few days, maybe it takes you an extra day to have done it with tests, but it's you're never going to have to do that day of manual testing again and again and again. So it's just worth it.
Yeah, I think that's the absolute critical thing, is you need to have leadership buy-in, and you need to have the budget to handle that, and the wherewithal to basically say, no, we have to do this automation. And I think the most important thing also to consider is, you mentioned, okay, this was needed for this particular feature, this particular functionality. So it increased the budget by 40% in terms of time, and you'll get the return on investment rather quickly. But I think the other critical thing on top of that is that your code is unlikely to break unless something changes. And the only reason something changes if another feature or another piece of functionality is added. Well, you have no idea how well your feature, the new feature, is going to interact with all of your old features unless you have the automated tests around it. And so that's oftentimes where the big benefits I see start coming in is when you run those tests locally and go, oh, when I added this statement or I added this class or I added this thing, I broke a whole bunch of tests and the things just aren't working anymore. Okay, something clearly went wrong. I'm clearly doing something wrong that caused all of these basically negative cases because of this feature that it shouldn't be interacting. So something was going on with this interaction. And I was able to find it now versus finding it much later. And I think there's another important study, and I can't remember which study it came out from, where it came out from, but it looks at the cost that it is to fix a problem or fix a bug exponentially increases as you get farther and farther away from the developer's machine. So once it reaches prod, it's exponentially more expensive to fix than it is on the developer's machine or inside of a local test environment or a dev environment.
That makes sense as well, because it's not just the fact that it's not fresh in your mind. If you just run the tests locally, in your mind, you know the exact lines of code that you've just changed. And so you know it's one of those that's broken it, right? So you've kind of like narrowed down a million lines of code to the 10 lines that you've just changed, which means that you can pinpoint really quickly. But as it gets further out, there's also all these coordination overheads, where it's now a customer has spoken to support. Support have had to route the error through maybe to second line or third line to get it fixed. Someone has to stick it on a task board and they have to kind of decide that that's the important thing to do. And then we have to go in and fix it. So it's like there's all this other cost in your organization from that failure demand that when a developer can run it locally and immediately and get that feedback, you haven't wasted all of the time of those other people and you haven't annoyed the customer. So it's like that's worth a lot more than the time it takes to implement tests.
The other thing that I love about when you automate your tests, be it a unit test or an integration test, and I had firsthand experience with this by a number of the different applications, was it created a framework for me to replicate problems that our customers encountered in production. Because no matter what, you're not going to be able to cover every possible use case, especially when you start getting into the level of integration tests, when you're testing multiple components together, not just a single unit of work. Having that framework was so beneficial. I remember a number of times I encountered it's like, oh, that's a really interesting use case. I never thought in a million years that would be like that. Like we don't have that in any of our lower environments, this particular customer's use case or this particular customer's configuration. Okay, I'm going to add that to my test suite and let's see what happens. And not only that, but I was able to replicate the issue so much faster. And I think that's a huge part of fixing bugs and getting your mean time to recovery reduced is to find and be able to replicate it. Half the time it's trying to figure out what's going wrong. Once you know what goes wrong, typically you can fix the bug. I would say the vast majority of the time fairly quickly because oftentimes it's something innocuous. It could be like a single line of code or a small block of code or an if then statement or a case statement or something like that that you just didn't think about. Oh, I didn't think about this particular case. But now you have that framework and it's so much faster.
That's right. It's 8 hours of pinpointing, and then it's like, oh, that I've put less than. It should be less than or equals.
Yeah.
So it's like the actual code change can be a single character, but the pinpointing takes hours. And I'd say that keeps extending backwards. The most successful team I've ever been on, we went into a room with the people that understood what the system needed to do and the problem it needed to solve. And we used pens on a great big window to write out examples and to use that as a jumping off point to have conversations. What if this happens? What if someone types this value in, And we had that conversation and that table of examples, we put that into a Gherkin scenario outline and used that to know when we'd completed work on that feature. And so we were, able to guarantee that we had delivered what we had discussed in that room each time we did it. So you kind of like, again, it brings it earlier. Now, instead of necessarily getting all the way to production and then saying, oh, there's some cases I didn't really think of, you're actually encouraging them to come up super early. So now even the requirements are better because we're thinking in terms of getting those examples and then we automate those examples. So it's just all round positive, and I'm surprised it's not kind of caught on and everyone does it because it feels like that should have happened now.
Well, I think again, it goes back to if you don't have leadership buy-in, if they don't see the value in testing, and don't see the value in automated testing because they came from oh, we can just do this manually. We can just click on this manually. What it's not that big of a deal. It's super easy to do. Why should I waste the time in doing something like that? And it's an unfortunate side effect, and thankfully, it happens less and less when we talk to folks, especially when we talk to customers. It happens less and less, but it's still out there. Just like there's still people out there that don't have version control. I remember going to a company even in 2008, and they weren't using version control. That everything was on a file share. I'm like, what is going on here? Like, how is this even possible? The other thing that I kind of wanted to ask you about this is so you use that example of getting into the room and writing down all the possible use cases. And is there a point in time in which you say that's an unreasonable, unfeasible use case that we shouldn't really support and it should throw an error versus let's just have a test and then fix the code because it makes the test pass?
I think that's the great thing about the workshop is that sometimes even a feature that sounds like it might be a good feature, sometimes when you reflect it back and pass it back and forth, it reveals a strategic weakness in what you're trying to do with the software. And I've had a couple of cases where they've said, actually, can we talk about a different feature instead? Because I'm having second thoughts about this. Like in terms of it sounds now much more complex for what should have just been like a little nice to have on the side. Maybe we shouldn't do this at all. And you move on, and then sometimes it will come back again after they've thought about it and they've gone, I've thought about it more, and now I know what we should do. And other times they're like, nah, that's just never going to happen. It turned out the idea just wasn't good. So yeah, you should definitely have an opportunity in that workshop to decide that you want to make sure that that exception scenario is handled nicely, so the user isn't presented with just a GUID and a good luck. We want to make sure that they actually have a nice pathway out of whatever happened. But it's perfectly valid to say to the user, I can't do the thing you're asking because the input you've given me isn't the kind of input I want to work with.
Yeah. So the reason why this came up is I remember very distinctly having a discussion or an argument with one of our QA folks in a company I worked for when I was a developer. A little bit of context. The software that I was working on was responsible for handling the amount of gasoline or petrol that you could pull from one of those massive, not the petrol stations, but the actual where they go and fill, where those tankers go and fill up those big, massive places where you see all of those, the massive storage units and everything like that. And so the way that it worked was it controlled the amount of petrol that you could lift per day. So it had a control in there. So you couldn't have a truck go by constantly and just refill their truck over and over and over again, this particular company. And this came about actually as a response to Hurricane Katrina. So in the United States, when Hurricane Katrina hit, one of the most interesting things is that a bunch of the different refinery stations, they were shut down because of damage to the pipeline, damage to the infrastructure. And everyone who owned one of those 10,000-gallon petrol trucks, they all went to these lifting stations and they all pulled oil out or gasoline out as fast as they could. And so then that jacked up the price to astronomical rates really, really, really quickly. So it's kind of they saw the problem was going to happen and then they just made it exponentially worse. Anyway, so with that all in mind, the discussion that I had is the QA person, they entered in something like 300 billion gallons that a truck is allowed to lift per day. And I said, well, that's more gasoline that's left on the face of the planet. I don't think a 10,000-gallon truck is going to be able to lift all that in a single day. Even if you had a fleet of trucks, that's a bit much. And so she's like, okay. She's like, well, what is the max? I go, well, because it's .NET. I go, what's an int max value? So it's 2.14, 2,147,000,000. And she goes, I guess that's an acceptable number. Like,
Yeah.
I think we can accept that that's enough petrol to fuel even the most inappropriately guzzling car.
yeah,
Yes.
yeah. I was like, wow. So, but it was an interesting discussion because it was really a case of what's an acceptable use case versus what's a not acceptable use case, and what really should you try to fix, especially when again it comes around automation, because again they're looking at oh, I'm gonna behave like a human, and I'm gonna come in here and I'm gonna start clicking all these different buttons and doing all these different things. But you gotta be realistic with this.
Yeah, I suppose is there a mindset shift even, I suppose, required for all of the automation, deployment automation? I'm a startup, YOLO, I want to do it all. Go. If let's say I'm in a more heavily regulated industry, financial services, anything like that, where there might be hesitation, people are like, no, we would rather Dave's team handholds lots more things, so he knows exactly what's. And do we see that mindset shift happening in the field, or has it happened, or again, is it just highly dependent on the scenario and the applications maybe that those teams are working on?
I would actually argue that companies that have more regulation are typically more prone to automation than not automation, just because it's much easier to pass your various auditing and your various compliance reports if you have to go through and if they say, well, okay, how do I know that this particular release was successful? How, because when you, again, I worked at a bank. Anytime we deployed to production, we had to get sign off from our business owner, and then we also had to get sign off from a QA person attesting to, hey, I tested this and I verified this and I had to go through all of this. And so typically you have to get multiple sign offs. Well, if you're trying to deploy faster to get a higher ROI, um, and you have to be compliant, well, the only way to do that is via automation. And so I think they're much more open to the automation than I would almost argue than a startup, because a startup oftentimes it's like, let's just get something out there. Let's just get something working and start getting feedback from our customers faster. And then we'll worry about some of the infrastructure and scaling problems later.
Yeah, it's definitely a day one thing to do, because if you build the habit from day one, you have automation that grows with you as you grow, and you never have that debt. I kind of feel, if you imagine you could buy gold at 5% below its market value, right, and you had money in your bank account, you'd be very sensible to just spend that money quickly, get that gold, and start selling the gold. But if you used an overdraft to buy that gold and you're paying 28% on your overdraft in order to get the gold at a 5% discount, that's not good value, right? So it stops being sensible. And with software, the overdraft comes super quick if you don't do automation. It's like it's not, oh, next year this will be a problem to solve. It's like, oh, 6 weeks in, we're already slowing down our feature delivery because we chose to do everything manually, and we've increased our failure demand because we're not spotting things in areas we didn't expect that we had changed. So it's you've got to kind of think of it from an economics point of view, and you can't go overdrawn with it because you can't afford the interest payments.
And on top of that, the other thing to kind of understand is as you grow, or as the application lives for not just months, but for years, it's unlikely to have the same developers, especially when you start working at larger corporations. Developers are going to come onto the team, be added to the team. They're going to leave the team, either leave the company or just leave the team. And without that suite of automated testing, that's really the institutional knowledge of your application and your application's business rules and how they should work, not what you think they should do. It's, we wrote these tests. This is what it should, this is how this functionality should behave. And that way, anyone who comes on board, they know, okay, these are the business rules. This is how it works. This is how they should interact. And so again, it's a long-term investment, not just a simple yes or no on something like that. So I have a small anecdote to share with you. That this actually, it was funny because I was talking with my parents last night, and we were talking about investing. And my mom said, "I have a story for you." I was like, "Okay." She goes, "Do you remember in the '90s I was part of an investment club?" I'm like, "Yeah." She goes, "Our investment club, we bought baby Berkshire Hathaway because they had just released it. Because Berkshire Hathaway A has always been crazy expensive. I don't know what it is right now, but it's really high up there. 'Cause, Warren famously doesn't do splits, and so baby Berkshire B was $25 a share. And if they had just stuck with it, I think last time I checked, it's like 2,000 a share. So again, it's that investment over time. It's a compounding thing.
Yeah, and that's the thing with all automation, is not just running the automation, it's capturing institutional knowledge and documenting it and stopping it from that. Like, everyone's done it where the deployment person has left the organization and you've been left with a checklist, and you faithfully go through the checklist and do every step, and you sit with someone, make sure I've done this step, look, the confirmation is there, it's correct, only to find that, of course, because they're doing the deployments all the time, there's loads of new stuff that isn't on the checklist because they didn't even look at the checklist when they were doing it. So the institutional knowledge walked out the door when they left, and now you have to identify all these gaps and fill them. And it's across all automation, the fact that it is a documentation that also runs and proves itself makes it really good at capturing valuable knowledge.
Yeah, I knew it was a slightly loaded question, but here we are. We got there. Steve, do you want to wrap us up with one of your insightful questions that you can put us on the spot with?
Your existential questions that causes me to think about it for the next week.
Yeah, well, so I've got the jump on you because I've already thought about the end question for today. I thought what I'd ask is one book that is going to help people with this continuous delivery journey. And it might be that it's an obvious choice of book, Continuous Delivery by Jez Humble and Dave Farley. Obviously, this is a good one.
It's on my shelf back there.
Or it might be a slightly less obvious one, Extreme Programming Explained by Kent Beck. You'll see this is like yellow and falling to pieces. I have to be careful that I hold it by the spine to keep the pages in. Or it might even be one of the weird book recommendations that I was given, which is a book called Seeing Like a State. And it's not about technology at all. It's about running a country. But when you start reading it, it's like, oh, it kind of is about technology, though. So, yeah, what book would you recommend to people going into this space?
Ooh, I think I've already talked about it today. I think it's The Art of Unit Testing. That was kind of an eye-opening book, especially the first, I want to say 8 or 10 chapters where it really talks about how to architect your application, how to handle these various dependencies. And it also really does a great job of explaining how do you handle certain dependencies that you don't have control over, like say the file system or your database? How do you abstract those away? And it gives you really practical, well-worn examples that lets you make it a testable thing, but not have to interact with, like, say, the file system or the database directly, which that was well, again, when I was a developer, that was a huge eye-opening experience when I started reading through that. I'm like, oh, wow. And it's a fast read. It's not, I mean, we're not talking 500 pages. I think it was like a couple hundred pages. And yeah, it was great.
I'm going to go with probably the Phoenix Project, and I know it's maybe more looking at it from a cultural shift and all of that stuff that goes with it. But and I haven't read the goal. I know you folks give the goal a shout out, so I will get to it. But the Phoenix Project was the first book that I read in this space that I wasn't expecting it to be a story per se. I was just expecting it to be like, oh, this is continuous delivery. Then you should do this, you should do that. And like within a chapter, I was like, oh, my word. Yes, I'm gonna. And like it's almost at the point where you couldn't put it down because you just wanted to sort of hear the story and see where it got to. But it was just very cleverly written in a way that's like, yep, I get it.
The Unicorn Project, which looks at it it's the same thing but from a different person's perspective, is also brilliant. And there's a little gang that meet up at the pub to try and make change happen, and that story is just so real.
Yeah. You know what's funny about the Phoenix Project is after I got hired at Octopus, so fun fact about me, I was one of the first US based hires. So it was myself and Ryan Russo. We both started on the same day, and we were the first US based hires. There was literally nothing in the United States in terms of infrastructure, in terms of onboarding, in terms of anything. So what did we do? We boarded a plane to Australia for 2 weeks. That was our onboarding. So we went down to Australia for 2 weeks. I'm like, well, even if Paul hates my guts, free trip to Australia. But as I was flying back, because I don't know if you've ever done the Brisbane to LAX flight, it's long. It's a bit long, And the thing is you board when you are flying home from Australia. You board at like 10 a.m. And so it's the middle of your day, and because your body's already adjusted, especially if you've been down there for 2 weeks. And so I'm like, I'm not gonna go to sleep, even though they turned out all the lights. So I had bought the Phoenix Project. I was like, I want to read this. And I started reading it on my Kindle on the plane, and I burned through that entire book on that single flight. I mean, that's how much of a page turner it was. I just couldn't put it down on something like that.
No one should be stuck inside a toothpaste tube for more than 3 hours. That's my opinion. That's the absolute limit. After that, I think it breaches your human rights.
How about you, Steve? What's your book choice?
We haven't pushed Toyota Production System actually in our conversations, and this is by Ono Taishi, who the way he describes things just brings it all to life. This idea of lean inside of a factory. So if you want to kind of go back to a really old book that talks about some of this stuff, Toyota Production System. I love that one.
Is that what they introduced the andon cord?
Yeah, they talk about that in there, and the visual signaling and these little tickets that move back and forward to make sure that you're only producing at the pace things are needed. That's brilliant.
I mean, that's the thing is like if you read through, say, the plan, or if you the goal, or if you read through the Phoenix Project or the Unicorn Project, it's all built on top of other work. And I think that's the most important thing is it's always fun to go back and read some of these source materials that the other authors then use for inspiration for their stories and what they're trying to teach.
Thank you all very much, folks. We will catch you next week for a topic to be confirmed, but it will be continuous delivery related. So thanks all for joining, and we will see you next time.
Bye-bye.
Have a good one, everyone. Bye.